Good morning, everyone. Today we're going to be reviewing Unit 6 over sequences and series. So let's start off with sequences. The very first question asks, what is the recursive rule for the arithmetic sequence? So two things to consider. Arithmetic means that this sequence is going to have a pattern that is either adding or subtracting. And a recursive is the one where you're going to have two pieces as part of your rule. So let's first figure out what the pattern is. So from 8 to 5, looks like they have to subtract 3, and then just make sure that that rule works every single time, which it does. So our common difference here is -3. So for our recursive rule, we always start by stating what the first number in the sequence is. So for this one, the first number is 8. So a sub 1 equals 8. Then we have to say how you would find any other term. So a sub n, that just stands for any term you want it to be, is equal to a sub n minus 1. And our pattern was to subtract 3, so we're going to put -3 at the end. And that is the recursive rule for this. Okay, the next one says, what is the 34th term in the arithmetic sequence? So again, it's arithmetic, so I know that the pattern is going to be either adding or subtracting. So let's look through and find out what our pattern is. So from 7 to 11, this time it's getting bigger. They are adding 4. And same thing here. So our common difference is 4. Now, it wants me to find the 34th number in this sequence. So I could, if I really wanted to, there's only 3 numbers here, just keep adding +4, +4, +4 until there's 34 numbers. Or I could find the explicit formula. So I'm actually going to write that here, explicit rule. And then that way I could just plug in the 34 and be done. So the equation for the explicit rule of an arithmetic sequence is a sub n d parentheses n minus 1 plus a sub 1. So let's plug in everything that we know. We know that d is 4. And we know that the first term in this sequence is 7, so +7 at the end. I'm going to simplify this. So you would have to distribute that 4 and then combine like terms. So eventually you would get the equation 4n plus 3. So that's the explicit rule. But they wanted us to find the 34th term. So now what I'm going to do is plug in 34 where the n is at. Just like that. So then in your calculator, you only have to type in what's after the equal sign. And I am getting 139. So if I were to continue that list, 139 would be the 34th number in that pattern. Okay, next one says find 3 arithmetic means between the numbers 11 and 35. So 3 arithmetic means. So you have to picture it this way. Somewhere there is a list that starts with 11, then there's 3 numbers, and then it's 35. So we want to figure out what 3 numbers go in between them. So if you think of this as a sequence, this would be a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So we're going to use the explicit rule that we used in number 2, but there's a few things that we need. We need to know what a sub 1 is, which we have right here in the front. N in this equation is going to be 5 because that was the number of the last term that we had. So that means that a sub 5 is the 35. So we're going to use both of those numbers in our formula. Okay, so I'm just going to write our formula so you can see what I'm doing. So we are going to fill this in. Okay, so instead of a sub n, we're using a sub 5, so 35 equals, we do not know what d is yet. N is 5 minus 1 plus 11. So we're going to simplify this. That way we can figure out what d equals. So I know that 5 minus 1 is 4, so that would be 4d plus 11. Subtract 11 from both sides, that would give me 24 equals 4d. Then divided by 4 would give me that 6 equals d. So that is the pattern here. They are going to be adding 6 every single time. So if I just pick up where they started, so they started at 11, plus 6 would be 17, plus another 6 would be 23, plus another 6 would be 29, and then plus another 6 would get you to the 35 that they had here. So those are the three numbers that go in between 11 and 35. Okay, so far all we've done are things that had to deal with arithmetic. Now let's look at geometric. So for this next one, it says, what is the recursive rule for the geometric sequence 16, 8, 2, or 4, 2? For geometric, either they're going to be multiplying or dividing. So from 16 to 8, that's dividing by 2. So you could say that they're multiplying by a half. So every single time, it's half of what it was before. So the common ratio is 1/2. So just like before, when it's a recursive rule, you always have to start off by stating what the first number in the sequence was. So A1 is 16. And then to find any term after that, so A sub n, it would be 1/2 times the previous term, just like this. Okay, our next one says, what is the 18th term in the geometric sequence 2, 6, 18? So 18th term, first we need to find what the pattern is. So from 2 to 6, they are multiplying times 3. Same thing here. So our common ratio is 3. So you could, if you really wanted to, we have 3 numbers here. So you could keep multiplying by 3 until you have 18 numbers, or you could use the explicit formula or explicit rule. So for geometric, it is A sub n equals A sub 1 times r raised up to the n minus 1 power. So just to fill this in, or let's actually write the rule. A sub 1 is 2 because that is the first number. Then we said that our ratio is 3 raised up to the n minus 1. So we're going to use that formula. So if I want to find the 18th number, let's plug in 18 where that n is at. And then just put this into the calculator. If you want, you can simplify it. 18 minus 1 is 17, so you could just plug in the 17. This is going to be a really, really big number because they're multiplying. And I get, yeah, really big number, 258,280,326. So this is what happens when I make up problems. On the test, I do not think there's going to be one that's that big, but hopefully not. Okay, and then next problem. Find two geometric means between 2 and 128. So two geometric means between those numbers. So I would have a sequence starting with 2, have 2 blank spaces, and then the 128. So what we need to do first is figure out the pattern that's going on. That way we can fill in those empty spaces. So we're going to use the explicit formula of a geometric sequence, which we just did in the previous problem. Looks like this. And let's fill in what we have. So our a sub n is 128. Our a sub 1 is 2. We don't know what our ratio is. But I do know that I have 4 terms here, so we're going to plug in the 4 for n. Okay, I know that 4 minus 1 is 3. So something like this. Divide both sides by 2 would give me 64 equals r cubed. And then if I wanted to get rid of that cubed there, we would do cube root. That is a button on your calculator. And I get 4. So the pattern in this geometric sequence is that they are multiplying by 4. So if I just pick up where they left off, 2 times 4 is 8. 8 times 4 is 32. And then if you want to check, you can do 32 times 4, and that gives you 128. So those are the 2 missing numbers. Okay, so that's all that we did for sequences. Now let's look at series. So series is when you're asked to find a sum. So just see the problem wording there. It says find the indicated sum. So they want us to start with the first term and end at the 12th term. So we need to find a list of 12 numbers and add all of those up. And this is the explicit rule for the sequence. It's going to help a lot if you can recognize what kind of sequence this is. So 2n minus 6, that's basically, or not basically, it is a linear equation. Y equals mx plus b. It's just with a different variable. So because it's linear, that means that it's arithmetic. This is important because an arithmetic series has its own formula. The formula for that is if you want the sum of the first n terms, it's n times a sub 1 plus a sub n over 2. So there's a few things that we need to find here. We need to know n, which it's always going to come from right here. It's 12, so we want the first 12 terms. We need to know a sub 1. Well, we find that by, well, here's our explicit formula. What happens when I plug in a 1 there? So 2 times 1 minus 6 gives me -4. And then I need to find a sub n, which we said n was 12. So if I plug my 12, I get 18. Okay, so now I have everything I need for my formula. So if I want the sum of the first 12 terms, that's going to be 12 times -4 plus 18 over 2. Just put that all into your calculator, and I get 84. So the hardest thing about this one, I think, is just recognizing that it's arithmetic, because on the test, it's not going to tell you. You're going to have to recognize it from this part. Okay, next problem. Says find the indicated sum. So this one, if you look closely at the what's in parentheses, that is not linear anymore. That is exponential. I know that because the n is an exponent. So exponential means that this is a geometric series. So this one has its own formula as well. S sub n equals a sub 1, 1 minus r raised up to the n power all over 1 minus r. Actually, hold on just a second. I put that exponent in the wrong spot exactly like I told you I do all the time. My n should be here. Okay, so looking at that formula, there's a few things I need. I need n, which is going to be 7, because that's up here. I need a1, and I need r. So r, you can get it directly from the formula. Whatever's being raised to the power, that is r. So r is 3. But to find a1, we're going to have to actually plug in a 1 here. So 2 times 3 to the 1 power, that gives us 6. So now just putting everything all together, the sum of the first 7 terms would be 6 parentheses 1 minus 3 raised up to the 7 divided by 1 minus 3. So if you put this all into the calculator, I get 6,558. Okay, let's take a look at the back of the page. So you also need to know how to do a word problem. You're going to have to recognize whether this is arithmetic or geometric on your own. But let's see what we got. It says, suppose you put $1.50 into a jar. The next week you put in $2. The next week you put in $2.50 and so on. What is the total amount of money at the end of 27 weeks? So far my sequence, or let's make it a series, is going to look like, sorry guys, is gonna look like $1.50 plus $2 plus $2.50, and then it's gonna keep going. So looking at this, the pattern that I'm seeing is that each week it's 50 cents more than the previous week. So since it's an adding amount, so from here to here, it's plus 50 cents. This is going to be arithmetic. And since it's 27 weeks, that is going to be n. So we can start by first figuring out how to find the 27th term. So a sub 27 would equal our common difference, which was 50 cents, n minus 1 plus $1.50. That's our first term. Okay, but I'm going to plug in our 27 now, minus. And I get that on the 27th week, you put in $14.50. So now I can fill in the formula for the partial sum. It always starts with the number of weeks, so 27, parentheses, add the first week, $1.50, plus the 27th week, $14.50, and divide by 2. So let's put this all into the calculator. And I get that at the end of 27 weeks, you will have collected $216. Okay, so that is series. Series is finding a sum. It's basically just formulas. So the last thing that we did in this unit is binomial expansions. So you could technically multiply x plus y. It's raised up to the 4th power, so you could do it 4 times, and it shouldn't be too difficult for you, but we could also just follow the pattern. So there's a few things that we need here. We need Pascal's triangle. So Pascal's triangle. It always starts with 1. We need to go up to 4 rows, so I'm going to do 4 rows. Then 1, 2, 1, 1, 3, 3, 1. So what I'm doing is just getting the diagonals and adding them. I know there's already 4 rows there, but I need one more because we technically start counting at 0. 1, 4, 6, 4, 1. So this is row 0, row 1, row 2, row 3, row 4. So just remember that it starts at 0. So right now, the one that they're asking us for is to the 4th power. So we are going to be using the 4th row. Okay, so I'm just going to write those numbers up here so that I don't forget. 1, 4, 6, 4, 1. Okay, the other pattern that we start off with is our first term. We're going to raise it to the 4th power. So x to the 4 The second term, we start at 0. So since it's starting at 0, I'm not going to write it. So x to the 4th is already our first term. Second term, start with our 4. That x, you're going to bring it down an exponent, and the y, you're going to bring it up an exponent. Next term, now I need the 6. So 6, x, bring it down 1, y, bring it up 1. Next term is 4. X is going to go down by 1, y is going to go up 1. Now, remember there is an invisible 1 there. I'm just not writing it. You don't need it, but it is there. Okay, and then last term has a coefficient of 1. I'm not going to write it. This x, if it went down an exponent, it would be 0, so I'm not going to write it as well. So the only thing that the last term needs is y to the 4th. Okay, now let's look at the next one. B plus 2 to the 3rd power. So I'm going to need the 3rd row of the triangle. So this row instead, 1, 3, 3, 1. 1, 3, 3, 1. Okay, but follow the same pattern. This one we are going to have to simplify a little bit. So if I'm following the pattern, I have a coefficient of 1. B is going to be to the 3rd power. 2 is going to be to the 0 power. Plus, the next coefficient is 3. B to the 2nd, because we're going down 1. 2 to the 1st, because that's going up. Plus, next coefficient is also 3. B to the 1, 2 to the 2. And then last term, starts with a 1. B to the 0, 2 to the 3. Okay, so I'm going to simplify. Anything to the 0 power, we don't need. The coefficients of 1, I don't really need to write. So this first term is just going to be b cubed. But this second term, it's going to have the b squared. That has to be there no matter what. But the other two things, the 3 and the 2, we need to combine. So 3 times 2 gives me 6. Plus, same thing here, I have b to the 1 power, so I still need that b. I'm not going to write the little 1. But the numbers we need to multiply. Make sure you do exponent first, so 2 to the 2nd power is 4. 4 times 3 is 12. And then last term, I just have 2 to the 3rd power, that is 8. 8 times 1 is still just 8. So that is our binomial expansion, it's all simplified. Okay. For 12 and 13, we're wanting to find specific elements in Pascal's triangle. So normally when you look it up, if you're lucky, it'll go up to about row 7 or 8. But once it gets past that, you're going to have to find it on your own. So if I want to find the 7th element in the 19th row of Pascal's triangle, you have to use a combination formula. That's the one with the factorials. So the combination, I'm going to write the formula for us. NR is equal to n factorial over r factorial n minus r factorial. Now, n stands for the row number and r stands for the element. So if we're looking for the 7th element, that's going to be r, and the 19th row, that's going to be n. So we're looking for the combination of 19, 7, and then fill all of this in. There is an exclamation mark button on the Inspire as well as in Desmo, so whichever one you like better you can use. Or there is a combination button in both the Inspire and also Desmo, so whichever one you prefer. But once you type this into your calculator, you should get, so I'm getting 50,388. So see, it's a lot faster to use this formula than it is to actually fill out the whole triangle. So let's do that one more time. Same formula, but it's going to be different numbers. find the 11th element in the 14th row of Pascal's triangle. So element is R, row is N. So I'm looking for the combination of 14, 11. So 14 factorial over 11 factorial, 14 minus 11 factorial, and that gives me 364. Okay, and then these last two examples, it's finding a specific term in the expansion. So instead of having to expand the whole thing out, what if I only wanted one term? So that's what we're going to do here. It wants the 7th term in this expansion, w plus 3 to the 9th. So the formula for this is you need to do the combination formula times the first term to the n minus r power, the second term just to the r power. So that's the formula that we're going to follow. That's the binomial theorem. Just be careful because it does say the 7th term, but that doesn't correspond with element. R is actually going to be 6, and then n is going to be 9 because that's the power that we're raising to. Okay, so combination of 9, 6 times our first term in this binomial is w. So w to the 9 minus 6 power. And then our second term is 3. So times 3 to the 6th power. Now, I'm pretty sure we all can see this right here. 9 minus 6 is 3. So our term is going to have w to the 3rd power, no matter what. But this and this are actual numbers. So you can type those into the calculator like we did just yesterday. It's going to be a big number. I get 61,236. So that's going to be the 7th term in that binomial expansion. Okay, so one more. What is the 4th term? So since it's asking for the 4th term, that means that r is going to be 3. In the expansion, 2x plus 3 to the 6. So n is going to be 6. Same formula. I'm just writing it again so that we have it. Okay, so we're going to do combination of 6, 3. Then a stands for our first term. Our first term is 2x. So 2x to the 6 minus 3 power. B stands for our second term, so 3 to the r power, which was 3. Okay, I'm going to simplify one more time before I type it in. So combination is still the same, but right here, 6 minus 3 is 3. That 3 needs to go to both things, so it'd be 2 to the 3rd, x to the 3rd, and then I still have 3 to the 3rd. This was a coincidence that it's all 3's. Okay, so no matter what, my term needs to have x to the 3rd because that's a variable. I can't really simplify that. But everything else is a number, so I should be able to combine it. So this would be a number, this is a number, this is a number. You could type it in all at once into your Inspire or into Desmos, and it'll give you a number. And I'm getting 4,320. Okay, so the 4th term in that expansion would be 4,320 x cubed. Okay, guys, and that's going to be the whole test. The test is going to be multiple choice like always, and you are allowed to use all of your notes, especially this review that we did just now. And just let me know if you have any questions over anything.